Greetings, students of chemistry. Sorry that I cannot be here today, but in my absence, I am really here with you. Today we're going to talk about acid-base reactions and problems involving that sort of stuff. And the reason why we're going to do that, guys, remember, is because your last thing you're going to do in my class is going to be an acid-base reaction called a titration. Okay, so as the week goes on, we're going to kind of build up to this, and I'm going to teach you guys what a titration is. But for today, you are going to do, in my absence, some problems with acids and bases. And just a review here, some schedule for the week, okay? Today, you guys will be working these problems on acids and bases, okay? Tomorrow, we're going to do a lab involving acids and bases. So, of course, what you guys need to wear are going to be closed-toe shoes, okay? Anybody who does not have the proper shoes and who refuses to wear the gross loners will not be able to participate. And yeah, you have to. It's a required grade. So make sure you wear the proper shoes. We're going to do calculations from the lab on the 18th, okay? So you're not going to have a whole lot of homework on this day, but on the 18th, we're going to do the calculations here in class, okay? And during, after school, during my tutoring hours that day, I remember I told you guys we'd have an extra credit lab where you guys are going to determine how much calcium is in a snake egg. Well, we're going to do that after school on Wednesday, so make sure you put that down on your calendar. Also, guys, Wednesday, if you guys missed the enzyme lab on last Friday, Wednesday after school is going to be the day to make that up. And I should warn you guys that after my tutoring days this week on Wednesday and Thursday, there will not be any further makeups for missed assignments or anything of that nature for chemistry. This is again because we're getting to the end of the year. So make sure that if you have something you need to make up because you're absent or sick or what have you, that you do it one of those days. On the 19th, we're not really sure we're doing that day yet, but be prepared for some kind of lab. And on the 20th, we're going to do a titration demonstration. You really want to make sure that you are here for this titration demonstration because on Monday and Tuesday of next week, you will be doing your own titration of an unknown. Okay, so here we go. Let's review a little bit. Things we've learned about acids and bases. I know it's been a little while, but let's review, okay? An acid, in case you guys forgot, is a substance, a chemical substance that donates an H+ ion, okay? Bases, we define in class as the opposite. There's something that accepts an H+ ion. And when these two things are mixed together, an acid and a base, they react, okay? What happens is that the acid donates an H+ ion to the base. It's like a transfer, kind of, okay? For example, let's do a reaction here, okay? Pretend that we mixed hydrochloric acid, HCl, and sodium hydroxide, okay? Now, if I was going to ask you guys which of these is an acid, of course, you're going to say, well, Mr. Harper, we know that HCl, this is an acid. We know that because we've memorized our 6 strong acids, which are HCl, HNO3, HBr, and several other things, but also because if we look here at the formula, this contains an ionizable hydrogen, obviously. We have the H here as being the first thing. So we know, because of that, that HCl is the acid. Over here, if we look at sodium hydroxide, here this has an OH ion in there. So if we look at the formula, we know that's going to be a base because it contains the OH. Okay, there we go. Now, these things are going to react. When they react, my hydrochloric acid is going to transfer a proton here to the sodium hydroxide. Okay, so when that happens, the H goes with the OH, and together, those make water, H2O. Also, when we do that, guys, remember that here my sodium ion is going to go with the chloride ion, and when we do that, we're going to get a unit of sodium chloride, which is why, if you guys remember back, we said that usually when an acid and a base react, they're going to make water and a salt, usually, okay? Let's look at another example. Here's another acid, HNO3. This is called nitric acid, okay? I'm going to react that with potassium hydroxide, KOH, okay? Now, when I do that in the same way, the acid is going to transfer a proton to the OH, okay, from the base, and we're going to get water. The other product of the reaction will be everything that's left. So we have the potassium ion. This is going to go with my NO3, which is altogether called nitrate, and we get KNO3, which is called potassium nitrate, and those are the products of the reaction, okay? One more. Here's a toughie. We're going to have HCl again. Here's my acid, and I'm going to react that with something called ammonia, which has a formula of NH3, okay? Now, if you guys remember back, when we discussed acids and bases, we said that ammonia is a base, but it's a little bit weird in a certain respect, okay? If we look at it here, ammonia doesn't contain any OHs in the formula. It's just NH3, okay? But it still behaves as a base because it is capable of accepting a proton, okay? So if that happens, here we go. So we're going to have my hydrogen here moves over and it gets donated here to the NH3. When that happens, NH3 plus a hydrogen makes NH4. Okay, but this is going to have a positive charge because remember, this is accepting an H plus ion. Then the other stuff, what we have left, is going to be just the remainder here of HCl, just the chloride ion by itself, which is going to be Cl minus. So there we go, guys. A review of how to write an acid-base reaction. Hopefully you guys recall that from before, okay? Now today we're not only going to be looking at acid-base reactions, but you guys are going to do some stoichiometry with acid-base reactions. So what I want to do, you guys should have the yellow worksheet in front of you guys right now in addition to your notes. I want to do 3 of these problems with you from the worksheet, okay? So we're going to do number 1 first, okay? Here we go. This is going to be problem number 1, okay? It says a volume of 30 milliliters of 0.25 molar hydrochloric acid, okay, neutralizes a 50 milliliter sample of potassium hydroxide solution. The question is, what is the concentration of potassium hydroxide? That's what we're trying to find here, guys, the overarching goal, okay? Now, to solve this problem, we're going to do a couple steps, okay? Step number one is we're going to write down the chemical equation, okay? If we do that, okay, here's my reactants. We have HCl. There's my acid, okay? And this is reacting here, it says, with potassium hydroxide, KOH. There's my other reactant. Now, in this reaction, let's write this down. These guys are going to make, okay, if I transfer my proton here to the base, we're going to make water, and we're going to make potassium chloride. That's the other product of the reaction. Now, if we look at this equation that we've just written down, this equation is balanced. We always have to make sure, guys, that the equation is balanced, okay? Here's the next thing we're going to do. The question we're trying to figure out is now, what is the concentration of the potassium hydroxide? That is the unknown, okay? This is going to be a stoichiometry problem. We have to start with something that we know, okay? And the thing that we know is this. We know the concentration of the acid, okay? This hydrochloric acid that we're using here, we know the concentration is 0.25 molar, and we know how much of it we start with. We start with 30 milliliters of that solution, okay? So that would be good information to start with. At the end of the problem, we're going to calculate the concentration of the potassium hydroxide, okay? Now, when we are calculating concentration, guys, remember, this is going to be in terms of molarity, okay? Which, if you guys remember, is going to be moles of potassium hydroxide divided by liters of the solution, okay? Now, we know the volume of the solution, okay? Here it is right here. It says the volume of potassium hydroxide is 50 milliliters. If we change that to liters, guys, we can very simply do that. That's 0.050 liters, okay? So we know this volume. We know that piece right there, okay? That's the volume of the solution. What we really need to know are how many moles of potassium hydroxide are there. That's what we need to find here by stoichiometry, okay? So let's do that. I'm going to start with this information right here. The volume of my acid solution is 30 milliliters, okay? I'm going to change that, though, first to liters, okay? I don't need to show that step because it's very easy. This is going to be 0.030 liters of that acid solution, okay? That's where we start, 0.030 liters of HCl, okay? Now, I want to change this volume here into moles. I'm given the molarity here, so I'm just going to multiply there by that ratio. 0.25 molar is the same thing as saying 0.25 moles of HCl per liter of solution. Okay, so I'm going to write that down instead. I can write down this ratio instead of 0.25 with a capital M. Okay, so it's going to be 0.25 moles of HCl divided by 1 liter of solution, okay? Now, when I do that, if you guys remember, my liters are going to cancel out. Now I have moles of HCl, okay? Now, what I want to find through the stoichiometry is how many moles of potassium hydroxide were there that reacted with it here, okay? So I'm going to multiply now by a mole ratio. If I look at the equation, I see that there's 1 mole of potassium hydroxide for every 1 mole of HCl in the reaction, okay? So moles of HCl cancels out. We're going to get moles of potassium hydroxide. If I go through here and do the math, plug the numbers into my calculator, I'm going to find that there were 0.0075 moles of potassium hydroxide in that sample that reacted, okay? But I'm not done yet. That's not the answer. This is how many moles of potassium hydroxide there were. What I want to find here at the end is the concentration. I want to find the molarity of the solution. So to do that, the molarity is going to be 0.0075 moles of potassium hydroxide divided by the volume of the potassium hydroxide solution, which we already identified was 50 milliliters or 0.050 liters. Okay? If I plug that in my calculator, do the division, I'm going to find the concentration of my potassium hydroxide was 0.15 molar. And there we go. That is the answer. We're going to box that because we're very proud of our answer. Okay? So that was problem number 1 off your worksheet. Pretty much every other problem is a similar kind of situation, but you have to identify the reaction that's taking place and then just do the stoichiometry. The numbers are different, but the procedure is going to be pretty much the same. Okay? Now, you're going to ask me, well, Mr. Harper, why are you making us do this here in the last couple of weeks of school? Well, the reason is because the experiment we're going to do during the last week is called a titration. We're going to identify the concentration of an unknown solution. That's what you guys are doing here in this problem. You're finding the concentration of the unknown potassium hydroxide solution. This is effectively what we're going to be doing in the lab, except here, you're doing it on paper. So let's do another one. Okay. This one right here is number 2 off your worksheet. Okay. It says a volume of 9 milliliters of 0.7 molar ammonia solution neutralizes or reacts completely with a 35 milliliter sample of perchloric acid, HClO4. What is the concentration of HClO4? That's my acid, okay, and ammonia here is going to be my base. So I'm going to first thing, guys, I'm going to write down a chemical equation to represent the reaction, which is going to look like this. We have my acid, which is HClO4. That's going to react with ammonia, NH3, okay. Now when they yield products, okay, this proton gets donated to the ammonia. I'm going to make ammonium, NH4+, and I'm going to get the rest here, this remainder, the perchlorate ion, which is ClO4-, okay. There's the chemical equation, and if we check, okay, to see that it's balanced, we see that in fact it is going to be balanced, okay? So, what I'm trying to find here at the end is the concentration of the perchloric acid. That's the unknown, okay? So now I'm going to do a stoichiometry. I'm going to do some stoichiometry. To find the concentration of HClO4, what I need to know is I need to know the moles of the HClO4, and I need to know the volume of that solution. The volume is given right here, so what I need to know are the moles of HClO4. That's what I'm trying to find. So I'm going to do some stoichiometry now. I'm going to start up here with the information for ammonia. I know the concentration, I know the volume, okay? So let's write this down. I'm going to change, though, right away, the milliliters here to liters. So 9 milliliters is the same thing as saying 0.009 liters of ammonia, okay? I want to change my volume into moles, so I'm going to multiply now by the molarity, which is 0.70 moles of ammonia per liter of the solution. Okay? Yeah, that's a little bit messy. Sorry, guys. Okay? Now, the next thing I'm going to do here is, now that I know the moles of ammonia, I'm going to change that mathematically to moles of perchloric acid. Okay? If I look at the chemical equation, there's 1 mole of ammonia for every 1 mole of HClO4, so I'm going to write that down. 1 mole of HClO4 to 1 mole of NH3. Okay? Moles of NH3 cancels out, and I'm going to get moles of HClO4. If I do the multiplication, I'm going to get 0.0063 moles of HClO4. Okay? Now if I want to know the molarity, okay, I'm going to take the moles, which is 0.0063 moles. I'm going to divide that by the volume of the solution, which we already identified was 35 milliliters, or I could change that into liters, and that is 0.035 liters. If I do the division, I'm going to get 0.18 moles per liter, or 0.18 molar. And there we go. That's the molarity of the unknown solution. Okay? Pretty much the same as what we did in number 1. Let's do one more. Okay? This is going to be problem number 8 off of your worksheet. Okay? What it says here is that a volume of 135 milliliters of 0.4 molar HCl, okay? Here's what we know right there. Neutralizes a 90 milliliter sample of calcium hydroxide, CaOH2, okay? What is the concentration of the calcium hydroxide solution, okay? First thing we're going to do, let's write down a chemical equation. We're going to have HCl reacts with calcium hydroxide. to yield products, okay? Now, really quick, right away, guys, we can figure out that if we look here at our acid and our base, here this acid has one H plus ion in it, but this calcium hydroxide has 2 hydroxide ions. This is a base, but each mole of this base has 2 moles, effectively, of hydroxide ion. So we know that for every one of these, we saw these before, guys, for every one of these that we have to have 2 of the acid molecules to react with it, okay? So when that happens, 2HCl reacts with one of these to give us 2 molecules of water, and then a calcium chloride, CaCl2. Yeah, there we go. There's our balanced equation. That one's a little bit tougher than the ones before, okay? Now we're going to go through and do some stoichiometry. What we're trying to find is a concentration of calcium hydroxide. To do that, I know the volume already. I need to know how many moles of calcium hydroxide were in the unknown sample, okay? So here, let's start. I have 135 milliliters of the known solution. I'm going to change that right away into liters. So that's going to be 0.135 liters of my HCl. Now I'm going to multiply that here by the molarity, which is 0.40 moles of HCl per liter. Okay, so liters cancels out. Now I'm going to multiply by a mole ratio. I want to change moles of HCl into moles of calcium hydroxide. So if we look at the balanced equation, I have 1 mole of calcium hydroxide for every 2 moles of HCl. Okay, that's going to cancel out there. Okay, and there we go. Let's multiply and divide. If we do that, we're going to find that we have 0.027 moles of calcium hydroxide. Okay, now if I want to find the molarity of my calcium hydroxide, just like we've done before, I'm going to take my moles of calcium hydroxide, which is 0.027. I'm going to divide that by the volume, which is 90 milliliters or 0.090 liters, okay? If I go through and do the division, I find the molarity is going to be 0.30 molar, okay? There we go. So the trick with this one, guys, was writing down the chemical equation. That's the whole trick here, and realizing, guys, that there's 2 HCl for every 1 mole of calcium hydroxide. There's a couple other problems like that on the worksheet where you guys are going to have to balance the equation, so make sure you don't get tripped up by that. Okay, that is all for today, guys, so make sure that you look at your notes when you're trying to solve these problems. I'll see you guys tomorrow, and have a nice day. Goodbye.